Okay, lesson 34. We're going to solve right triangles part 2. We're going to go a little further than we did yesterday, just a little bit further. Now, we're going to use the same 3 tools as yesterday. Do you remember what the same 3 tools were? We were using, well, let's see. I think the first thing I listed as a tool was good old SOHCAHTOA, which is kind of like a 3-in-1 tool, I guess, because it stands for 3 formulas, right? The sine is the opposite over the hypotenuse. The cosine is the adjacent over the hypotenuse. The tangent is the opposite over the adjacent. We have Pythagorean theorem, and usually you use that if you have 2 sides figured out already. You can figure out the leftover side by using Pythagorean theorem, and I've decided to write it this way. A squared plus b squared equals the hypotenuse has to go over there. That's why I'm writing it in a weird way. That has to be the hypotenuse. The hypotenuse has to go on the right side of the equation. Now the a and the b, it kind of doesn't matter which way you label those. You can put the a, the b there. You can put the a, the b the other way around. Doesn't matter. They're the legs, the 2 legs, the 2 smaller sides, the 2 legs. The h is the hypotenuse. The h has to go on the right of that formula. That's the big thing. And then there was a third tool. Remember this one? And this is for right triangles. Maybe I should put this up here as a little bit of a, well, it's not a disclaimer really, it's a condition. For right triangles, the acute angles add to 90 degrees. Acute in a math class means less than 90 degrees, and obtuse means greater than 90 degrees, and a right angle equals 90 degrees. So you have three classes of angles generally, acute, obtuse, and right. So when I say the acute angles, what I really mean is don't count that one. That's a right angle. The 2 acute angles. So this angle and this angle have to add to 90. It's a nice little shortcut you can take sometimes. You know one angle, you can get the other. That's kind of interesting. I just thought of that. If you know one angle, you can get the other. If you know 2 sides, you can get the other using Pythag. And if neither one of those is doing anything for you, you basically got to use your SOHCAHTOA. Okay, those are our 3 tools. Now, there's a little bit different thing going to happen today, and it's going to happen right here. What's going to happen today? I don't know if you remember, but last time, all the homework that we did, all the examples that we did, we were always given one of the angles. We were told, hey, that's a 17, hey, that's a 22, whatever. We were given one of the angles. But if you look at these 2 triangles, it's like, hey, they're not giving us any angles. What do they want us to do? Solve it ourselves? And the answer is yes, they want us to solve it ourselves. So let's solve for that angle theta. How? Well, it's the same, I'm looking at this triangle, it's the same SOHCAHTOA stuff. So what you got to do is you got to use your information and say, okay, if I wanted to form a trig function using these 2 sides somehow, then the question is, do I cross this way? Do I cross this way? Do I call it a sine, a cosine, or a tangent? So it might be a good idea to, well, if you're like me and you have it memorized, you say, hey, I reach through to the other side of the triangle, which is the opposite side. I come over to hypotenuse, and I call that the sine of theta. If you're doing it that way, wonderful. If you're not doing it that way, that works too. Well, actually, you have to do it a little differently, don't you? So if you're not going to do it that way, if you're not going to take the visual approach, you're going to have to say, okay, I got to label my sides. And that's the hypotenuse. Yep. The big side. And then remember, when you come through the middle of the triangle to get to the opposite side, you call it the opposite side. And so that's telling us, that we are talking about an opposite and a hypotenuse. So in your little SOHCAHTOA thing, if we're talking opposite and hypotenuse, we're talking sine. And then you can, I'm just going to take the SOH and I'm going to say this is the formula. Sine of theta is opposite over hypotenuse. So to put the stuff that we know in, we plug in stuff into the equation, right? And it's like this time we don't know what theta is, so we just have to leave it as a theta. We do know the opposite is 18.7. We do know the hypotenuse is 23.1. So I suppose what I could do is I could get out my trusty calculator device 18.7 divided by 23.1. And I'll write that as a decimal. And I'm going to carry some decimal places here. You want to do that. 809, what do we got here? 5, 2, I guess. 5 decimal places is probably pretty good. Don't just use 2 or 3. Use like 5. It's more accurate that way. Now, how are we going to get theta? Well, what you're not going to do, you're not going to hit the sine button. If you did the sine of 0.80952, and I'll do that right now, just for kicks, sine of 0.8092, oops, 80952 is what I really mean. Turns out the sine of 0.80952 is 0.014. Huh. Do you really think that's a 0.014 degree angle? No, it's not a 0.014. It's not that small. It's not that small. So you're not doing it this way. Nope, nope, you're not. Well, how are you going to get it then? Well, if we had one of those tables, it'd be fine. You know, we'd have no problem at all. You go to one of those tables where they have theta, and then they put the sine here, and the cosine here, and the tangent here. You could look down in the table until you found, see, what we said here is the sine of the angle is 0.80952. So you'd look down here, you'd come down in the sine column until you found the 0.80952, and then you'd cross-reference and say, oh, that's what the angle is. Now, you can do that with your calculator. But remember, when we hit the sine button, whoops, come on, why is it black and white? That was weird. Okay, so when you hit the sine button, it's kind of like, you know, if you had 45 degrees and then you hit the sine button, sine of 45, you're going to get 0.707. Well, that's how you go this way. So hitting the sine button has you look up to the right. We want to go to the left, so guess what? We hit the shift sign. Shift sign to go that way. So what we really want to do is we want to do the shift sign of the 0.80952. And that will tell us what the theta is. So this is something you're going to have to keep straight, okay? There's different ways of keeping it straight. One way is to say, well, you know what? I was trying to find the angle, so I have to hit the shift button. I didn't have the angle. I wanted the angle, so I have to hit the shift button. Another way to do it is if you were, well, some of you have taken college algebra already, and if you have, you might remember something about an inverse function. It takes the input and the output and it messes it up, or not messes it up, reverses it. So like the sine is a function. You plug the angle in and you get a decimal. Well, if you hit the inverse sine, which is what shift sign is, then you plug the output in, you get back your input, you get back the angle that it used to be. If you're in a college algebra kind of a mood, that might work for you. I usually think in terms, because I'm so visual, I usually think in terms of if I were looking up on the chart, I would be trying to go the other way. It's like, hey, I got the sign. I'm trying to go the other way. I'm trying to go to the left. And so you have to hit the shift first. The official name for the shift sign is the arc sign, and that word never made any sense to me at all. And I've noticed it seems to not get used so much anymore. So it's one of those old-fashioned things that might be going away. Inverse sine is commonly used. Now that's the actual symbol for inverse sine. A sign with looks like an exponent, but it's not an exponent. Not an exponent. So it says inverse. It's a notation for inverse. However you do it, you hit the shift sign. So I'm going to do that now. I'm going to go shift sign. Then I put the 0.80952 in there. And then when I hit equals, it tells me the answer. And this makes a lot more sense. 54 point, I guess I can go 2 decimal places. 54.05 degrees. Doesn't that look a little better? Now, actually, I'm not saying that I drew the triangle to scale, but triangle doesn't look like it's that far off a scale, and so the angle, it's got to be about 54 degrees. Cool, I can dig it. Did you catch that? The big difference is hit the shift sign. Now, what I'm going to need to do is I'm going to need to get all of this stuff out of the way. Get out of the way. Is that as small as I can go? Ooh, look how small I can go. That's nifty. All right, so anyway, let's look at this other problem. What do you think of this other problem here? We want to find that angle. Well, the information we're given is these two sides. I got a this side, I got a this side. I need to form a ratio of those two sides. It'll be one of my trig ratios. Which one? I don't know until I figure it out. So you have to say, which way am I crossing the triangle here? Notice we're not using the hypotenuse. That's always the tangent. If you don't use the hypotenuse, it's the tangent. Sine and cosine both go over hypotenuse, right? S-O-H-C-A-H, SOCA. Sine and cosine both go over the hypotenuse. So if you're not using the hypotenuse, you're a tangent. And that's all there is to it. You're a tangent. And you might remember something about my saying, be careful of the tangent, will smack you right in the face. So you go that way. That's the tangent. Of course, you could also label the sides. That's the hypotenuse. You have to go through the triangle to get to the opposite side. And then I'm standing on or right next to the adjacent side. And so notice that I have the opposite side. I have the adjacent side. I'm definitely using a TOA here. I'm definitely using this formula. The tangent of an angle is its opposite over its adjacent. So the tangent of that angle that I don't know, so I can't plug it in because I don't know, I just have to say theta. The tangent of that theta is, take the opposite side, 46.3, take the adjacent side, 98.7, and you may want to make a decimal out of that. 46.3 divided by 98.7, boom. What have I got here? I got like a 0.469, 469, and I'm going to carry 6 decimal places. 098. Good. So now what I got to do is I got to do the shift tangent, otherwise known as the inverse tangent. And again, that's not an exponent. And I point that out, maybe I should really point that out, not an exponent. And the reason I'm pointing that out is because I've seen people try to use that. If you look at your calculator has an x to the minus 1 button. That's not involved here. That's got nothing to do with this. That is an exponent. It basically means reciprocal. That's not what this is. You're hitting the shift and then you're hitting the tangent. Promise me. Shift and then the tangent. And then I put this number in there and it will tell me back the angle. Again, it's kind of like I'm going to the big old table, but I'm trying to go to the left. I'm trying to take the tangent, turn it back into a theta. I'm going to the left. I need my shift button. 0.469, 098, shift tangent. I got the 25.13 degrees. Make sure that looks more or less okay. That looks more or less okay. 25.13 degrees. Cool. So now you know how to solve for angles. It involves the all-important shift with your trig functions. If you're trying to find the theta, you're going to need to use your shift. Shift to find the theta. Seems like there should be a jingle in there somewhere. Shift to find your theta. Some kind of Monty Python thing, right? Shift to find your theta. Do-do-do-do-do. Have somebody throw a fish at him or something. Come on, you. I'm trying to minimize you. Come. Okay, here's the thing. Computers, right? They're the best things in the world. Why don't they always do what you say? Okay, here we go. Get that out of the way. All right, so that was page 1. What was page 1? Page 1 was, first of all, remembering our 3 tools. And then I had to show you this new maneuver that we're gonna face today, and that's the old solving for an unknown theta. You need the shift key. So I think we'll do just 2 more examples, I think. Putting it all together, using all 3 of our tools to find all the missing dimensions. Hey, that's cute. Find all the missing dimensions of our triangle here. It's a right triangle, so that's good. Cool. Let's find all the rest of the dimensions. Well, here they did give us an angle, so that's cool. I like that. I like it when they give us an angle. I guess that means that we can find this other angle right away, right? 41 plus what equals 90? Let's see, you'd have to go 51, 61, 71, 81. So you'd have to go another 49 degrees. You can always just spot check. Just go, if I add these, do I get 90? 40, 90, 90. Yeah, I get 90. It's always a good idea to just check yourself real quick. Well, there, I got that part. Now we're missing this side, and I might as well call it X for now. And we're missing this side, and I might as well call that Y for now. So we're going to have to, you can't use Pythag theorem yet because you only know one side, right? If you knew two sides, you could Pythag, but we only know one side, so it's SOHCAHTOA time. I'm going to use the angle they gave me. It's just a good habit. I'm going to use the angle they gave me. I have to use the 28. That's the only other piece of information that I actually know. And I can solve for X or Y. It doesn't matter which one I do first. I'm just going to choose for X first. So, what kind of a trig function uses the X and the 28? And which way do you cross? Do you remember this little thing? I reach through to the other side of the triangle, I come over to hypotenuse, and I'm a sine. Do you remember that thing? If you don't, then what you're got to do then what you got to do then is you're going to have to label your sides. So you say, well, that's the hypotenuse. It's the big side. It happens to be across from the 90, which means it's the big side. That's the 28. And then this, well, again, I'm coming through to the opposite side of the triangle, so that's the opposite. So you'd say, I'm using an opposite with a hypotenuse. And then if your little SOHCAHTOA, if you got that over here, you can say, oh, opposite and hypotenuse. This is indeed a sine, okay? So you can do it that way, or once you've done a million of these, I'm sure you're going to start doing what I do. Reach it through to the opposite side and go over the hypotenuse and call it a sine. Faster once you get used to it. Hey, you know what you might want to do is just put this on your mirror. Put this, hang this from your rear view mirror. Get a tattoo. Anyway, where was I? Oh yeah, we're doing the sine. So, the sine of theta is its opposite over the hypotenuse. That's what SOH tells us. It tells us that formula. It's a way to remember the formula. The sine of theta is the opposite of the hypotenuse. We know what the theta is, yay, yay. And then we say we know, well, we don't know what the opposite is. It's 8x actually. And then the hypotenuse is 28. So if you wanted to, you could say put this over 1 and do cross products, 1 times x. And it looks like I have 28 multiplying the sine of 41 degrees. And that's all you got to do is get out your calculator and say 2, 8, sine button 41, close parentheses, equals, and it's just about an 18.4. They gave us a whole number. That means I usually like to go like maybe one more decimal place. It's just a habit. You want to go 2 more decimal places? That's fine with me. 18.4. I just solved for this side. I should be happy. Look at that. I solved for this side. 18.4. We're moving. We're moving. What's left? I got to get y, right? Let's change colors for that. I got to get my y. Well, you could do SOHCAHTOA stuff again. But remember, like I say, once you've got 2 sides, Pythag can come right in there and give you the other answer in no time at all. The important thing is, I'm calling this an H, right? Most times when you see the Pythag formula, they put a C there. I'm calling it H because I've got to remember, hypotenuse goes over here. That's where the hypotenuse goes. And the hypotenuse is 28. So I know that the 28 has to go here. Again, the a squared, b squared doesn't matter so much. So I'll put the, as long as one of each is, as long as they're the legs. So one of my legs came out to 18.4. I'm going to have to square that. And I guess I can, well, I just call it a b because that's what the formula calls it, but it's y. Might as well call it what it is. So 18.4 squared plus y squared equals 28 squared. SBS means subtract both sides. Y squared is equal to 28 squared minus an 18.4 squared. Take the square root of both sides, and by that I mean put that whole thing inside of a big square root. This is the kind of thing that you can enter in your calculator, right? We saw that in Unit 1. You can do all kinds of cool stuff with the special calculator. So you can just hit the square root button. You can hit the 28. You can hit the square button. You can hit the minus and make sure you're still underneath the square root when you're doing this part. You type in the 18.4. You hit the square button and you hit the equals button. And then you hit the SD button. And you end up with what? You end up with y equals like 21 point 1 if I round to 1 decimal place. 21.1. And you'll notice we've got the entire triangle solved. I know that's 90. I know that angle. I know that angle. I know that side. I know that side. I know that side. All done. Cool. One more example. I wonder if you'd want to pause the video and try this one yourself for a minute. This stuff takes a little getting used to at first, but once you've done enough of these things, you'll be like a natural. You'll be a pro. So let's see, where should we start? Well, you can start wherever you want. You know what I'm going to do is I'm going to start with Pythag this time, because I notice I have two sides. So what do you want to call this side? I'll call it X for now. So what I can do is I can say, okay, Pythag is this, a squared plus b squared equals hypotenuse squared. And the hypotenuse is the 26, so that has to go there. So I got 19 squared plus x squared equals 26 squared. Subtract this on both sides, that's what SBS stands for. I got 26 squared minus 19 squared. If I just write it like this, it saves me a lot of button pushing, you know. Then I have to take the square root of both sides, make sure you're putting everything in the square root, like this. It's all in the square root. Don't do this. That doesn't work. You can't just take the square root of this, the square root of this, and the square root of this. It doesn't work that way. You have to put the whole darn side in the square root. So with that as a warning, let's see now here. I guess I'll just grab out my calculator is what I'll do, because I can just type that in the way it looks. Hit the square root button, hit the 26, hit the square, hit the minus, hit the 19, hit the square, hit the equals, boom. Hit the SD, boom. Now we're talking boom. 17 point, and I'll round it to one extra decimal place. 17.7. We've got all three sides. Pretty good. Problem is we don't have either one of our angles. So we need an angle. Now, what I like to do when I'm calculating angles is I like to use the two sides that they gave me. Because this number, it could be a little off. You know, well, I did round it for one thing. It's a little off. So I don't want to use the little off number. I want to use the two numbers that were given. You presume those are the most accurate numbers we got. So I'm going to use those two numbers. Oh, why'd you do that? Just take that part off. There we go. I want to use those two numbers, and I could solve for this angle. I could solve for this angle, right? It doesn't matter which one I do first. This one's, I don't know, it seems more comfortable to me. I like it. It's in a good spot. So I'm going to solve for that angle, which means the question is, which trig function is going to use those two sides? Now, if you know Tony, you remember Tony. Tony, he goes like this. He goes, it starts by the chin, and he goes over the hypotenuse. That's a Tony, and Tony's a cosine. Tony cosine. And if you don't remember that, then of course you have to say, okay, what are my sides? I know that's the hypotenuse because it's the big side. And I'm stepping on this side, so that's adjacent to me, right? So that's, well, it is the adjacent and the hypotenuse. And in the SOHCAHTOA lingo, you'd have the CAH for ka, for cosine. And so here's our formula. Cosine of that angle is going to be the adjacent over the hypotenuse. Plugging in what we know. Well, we don't know theta, but we do know the adjacent's 19. We do know the hypotenuse is 26. And so the cosine of theta is, I could make a decimal if I wanted to. You know, I can skip this step really, but I'm going to do it. 19 divided by 26 is, as a decimal, 0.73, and you want to carry a few, 0.730769. Carry 5 or 6 decimal places. And then remember, to get the theta, you have to do shift cosine. That's how you get the theta out. Shift cosine, and you put this in there, like that. That's how you get the theta. Shift cosine of that stuff. So I'm going to go on my calculator, shift cosine, hit the ANS answer key, so it just puts that decimal in there for me, and then I can hit equals, and it's telling me that we got just about a 43 point, how accurate do I want to say this? I'm tempted to say 43.0 degrees. If you go one more place, it would be 43.05 degrees. That's what I always hated about rounding, You know, it's like, it's 43.1. Is it 43.0? Well, that's a 5, and 5 is so in the middle. I hate that. Anyway, that's a math twitch. It's just one of my own math twitches. If you use two decimal places, 43.05. I'm not sure that's justified, but we'll just do it anyway. 43.05 degrees. That's this angle. Now we just need this angle. Well, remember, they add to 90, so all I really got to do is take 90 minus 43.05. So 90 take away 43.05 is 46.95. That's that angle. This is degrees, by the way. That's that angle. We got everything, right? We got all the sides. We got all the angles. We're as happy as can be. Cool!